Welcome to the ultimate walkthrough of the professional IDF curve and design storm template. If you're a civil engineer, hydrologist, or infrastructure planner, you know that calculating accurate rainfall intensity and generating reliable design storms is one of the most critical yet time-consuming steps in any water resource project. A single mistake can compromise an entire drainage or flood mitigation system. That is exactly why this professional-grade engineering tool was developed. It eliminates manual errors, automates complex iterations, and bridges the gap between raw data and actionable engineering design. Built to meet international standards, this template seamlessly accommodates both metric SI units and Imperial US customary systems. Today, we're going to dive deep into how this powerhouse template operates sheet by sheet, so you can see exactly how it will transform your engineering workflow, save you hours of manual calculations, and impress your clients or senior stakeholders. Let's get started. Let's look at our first core workspace, the Parameters, IDF, and Hydrograph sheet. Think of this sheet as the command center of your entire study. This is where you establish your project identity and input your foundational hydrology data. But here's where the true brilliance of this template shines: the unit conversion table. With just one click, you can switch the entire template between metric SI units, like millimeters, and Imperial US customary units, like inches. The template instantly adjusts its boundaries and formulas automatically. No more manual math, no more dangerous unit conversion mistakes. Now let's move to the heart of the analytical engine, the IDF analysis and hydrograph sheet. If you only possess daily rainfall data, such as a 24-hour maximum depth, your primary engineering challenge is to decompose that daily number into precise, short-duration hourly intensities. Traditionally, this requires hours of tedious setup. In this template, it happens instantaneously. This sheet contains two massive analytical steps. First, it features the empirical methods engine. It takes your daily rainfall data and breaks it down using four of the world's most widely accepted empirical models: the Mononode method, the Van Breen method, the Haspers-Wedewin method, and the Bell and Tanimoto method. For each model, a fully automated calculation table generates rainfall intensities across standard concentration durations, from 60 minutes up to a full 24 hours. To give you immediate visual clarity, each model automatically plots its own planned rain intensity graph right next to the tables. Second, once the empirical breakdown is complete, you can choose the most appropriate model to feed into the IDF curve-fitting formulations. This section automates three legendary parameter fitting models: the Talbot model, the Sherman model, and the Ishiguro model. The spreadsheet executes a rigorous mathematical regression to solve for parameter A, B, and N for every single return period. Look at the precision layout. It calculates the duration products, logarithmic regressions, and square root transformations effortlessly. But we didn't stop at intensity curves. Scroll further down and you will discover the design hydrograph construction tables. Using the globally standard alternating block method, or ABM, the template automatically structures a time-step hydrograph plan for each return period, including the extreme 1,000-year storm event. It calculates incremental depths, percentages, and exact time blocks to generate the perfect synthetic design storm pattern. This output is ready to be directly plugged into your hydraulic routing models, like HEC-RAS or SWMM. Finally, let's examine the third workspace, the summary IDF and hydrograph sheet. In professional engineering practice, your clients, managers, or checking authorities rarely have the time to audit thousands of raw spreadsheet cells. They need a clean, undeniable senior-level summary. This sheet is designed exactly for that purpose. It brings together all project identifiers, the chosen time of concentration, and the peak rainfall intensities into a centralized dashboard. It displays side-by-side comparisons of the empirical methods used and highlights the final selection among the Talbot, Sherman, and Ishiguro models. The formatting is pristine, executive-ready, and optimized for exporting straight into your final engineering reports or presentation decks. It beautifully summarizes the alternating block method distribution, giving you an instantaneous view of how the rainfall peaks over time. It gives your projects a premium, highly professional look that builds immediate trust with reviewing agencies. In summary, this professional IDF curve and design storm template is not just a spreadsheet. It is an engineered asset designed to protect your time and elevate your design accuracy. By unifying metadata setup, unit switching, 4 empirical decomposition models, 3 advanced regression methods, and automated ABM hydrograph generation into a single fluid workflow, you save days of manual calculation. Don't spend another hour building hydrology formulas from scratch or wrestling with unit conversions. Join thousands of engineering professionals who are upgrading their toolkits with premium templates. Click the link below to get your copy today. Streamline your next drainage project and design with absolute confidence. Thank you for listening, and happy engineering.